No need for that.
Okay, good evening, ladies and gentlemen. You're welcome to this class. In this video, we'll be looking at Laplace transform. As simple as ABC. It is not difficult. So, in our class today, in the morning, we did some revision on how to integrate definite integrals and indefinite integrals. So Laplace transform is mostly on definite integrals, and we are going to prove some properties of Laplace transform that is useful or important as long as Laplace transform is concerned. Okay, so tonight I'm going to define Laplace transform mathematically. It is defined mathematically as Laplace of f of t close bracket. This is the same thing as f of s. This is equals to integral 0 to infinity exponential minus st f of t dt. This is the mathematical definition of Laplace transform. Hope you are seeing the board clearly. It's okay. Please try and invite others who are not around. It's okay. So that is that. Okay. So far so good. So this is the mathematical definition for Laplace transform. So we are going to start proving the properties, how we are going to prove them. Is that clear? Okay, so let's fix IBM with excuse me, one of the examples prove that or prove that or show prove that Laplace of 1 is equals to 1 all over s. Okay, it's simple as ABC. Amen. It's simple as ABC. So let's look at it together. At first, you define your Laplace transform mathematically. Is given as Laplace of f of t is given as what? Integral 0 to infinity exponential minus st f of t dt. Amen. Amen. Are you following? Are you following? Okay. So far so good. So this implies that our f of t here is what? 1. Look at it here. Is that clear? f of t here is 1, right? So what we need to do, instead of this f of t, we write what? 1 here. So here will now be equals to integral 0 to infinity exponential minus st. Instead of f of t, look at it here, is 1, open bracket, 1 times the t. So if you agree with me, this 1 times exponential is 1 times the t is 1. So this is now equals to integral 0 to infinity exponential minus st dt. Can you see now? So it means we can integrate this function with respect to what? T. So this will now be equals to, if you can see what I am saying, look at the board. This is now equals to what? If we integrate this exponential minus st, we are going to have minus exponential minus st all over s at 0 to infinity, right? This is what we are supposed to have. So if you agree with me, we have to substitute the intervals. That is, subtract the lower limit from the upper limit. Is that clear? So this will now be, mind you, we have minus exponential, so minus exponential minus s. Instead of t, we write what? Infinity times infinity all over s, then minus the lower limit, minus open brackets, already we have minus here again, two of us, so minus exponential minus s times, anywhere you see t, you substitute in for what? 0, 0, right? Close the bracket, all over what? S. Any question, please ask. Oh, I should take it all over again. Abubakar, is okay. I will take it all over again. It's okay. I know you are just coming. Maybe you came late. Okay. Yeah. What I'm trying to say is this. It's nothing but we are just trying to define Laplace transform mathematically. Mathematically, it is defined as Laplace of f of t equals to f of s is equals to integral 0 to infinity exponential minus st f of t dt. This is the formula for Laplace transform. So, assuming you are asked to prove that Laplace of 1, this is the function, is equals to, show that this is equals to 1 over s, and that is what we are trying to do. So what you need to do first is for you to, after writing solution, you now recall the Laplace transform formula. This is it. Exponential, Laplace of f of t is equals to integral 0 to what? Infinity exponential minus st f of t dt. So now, I told you that, look at it. Laplace of f of t is this one. So anywhere you see f of t, instead of whatever that is there, you write it here. F of t is 1, two of us. So as you can see, look at it here. Integral 0 to infinity exponential minus st, open bracket. Instead of f of t, we write what? 1. Can you see now? So you know that if we use 1 to multiply this and this, is the same thing, two of us. Yeah. So that is why we obtained this. So at this point, what you need to do, you have to integrate this function, integral 0 to infinity exponential minus st dt. So if we integrate this function, this is what we are supposed to have. Look at it here, see it here. We are going to have minus, we did that in class, two of us, this morning, if I'm not mistaken. Yeah, we are going to have minus exponential minus st all over what? S at 0 to what? Infinity. So at this point, you are going to subtract the lower limit from the upper limit. True or false? It's true, right? Okay. So if we do that, it means this is how it will look like. Minus exponential minus s, anywhere you see t, you substitute in infinity. That is why you are saying infinity all over s minus, because we are subtracting this lower limit from this upper limit. So that is why you are saying the minus there. But already we have the function here, negative sign here. So minus this, anywhere you see t, you put 0. Do you understand? Any question? Do you have any question? Yes or no? Okay, so can we proceed? Yes or no, please? Somebody should answer me, please. Yes or no? Yeah, somebody is saying, I don't understand. I know. The reason why you don't understand, you were not in class this morning. That is why you don't understand. Yeah, it's okay. So we can proceed, right? Okay. So go back to our class this morning. I said, for the fact that we have infinity here, here is 0. Whole of this is 0, right? So then whole of this is 0. So here will be 0. Minus times minus plus, right? Then minus s times 0 is 0. So exponential 0 all over s. Can you see now? So this will be equals to, go back to your ND, your algebra. Anything raised to power 0, that is in indices, is 1, right? So exponential 0 is what? 1 all over what? So can you see now? It is proof. Look at it here. So this satisfies the proof. Can you see now? Any question? Please look at the board. If there is no question, let's move further to consider more examples. No question? Yes or no? The class is very few, it's only 34 students that are here out of 100 and something. Okay, Aliu, Ibrahim, we can move on, right? Please, I want you to like. Oh, yeah, we got the final answer. Look at it. Somebody is asking, let me clean here, then look at how we got the final answer. Look at it. Look at it, yeah. Somebody is asking. We are subtracting the lower limit here. This is the lower limit. Here is 0 from the upper limit. This is what? Infinity, right? So when you come across something of this form, it means we have minus exponential minus s. So anywhere you see t, you substitute in for this infinity. So that is why minus s, open bracket, infinity, then all over what? S. Then it says subtract the lower limit from the what? Upper limit. So minus, open bracket, you still write this function. minus exponential minus s open bracket. Here is t. So instead of t, you substitute for what? 0, 0, close bracket, all over what? S. Can you see now? Hope you are following. Can you see now? I want to show you how we arrive at the final answer. So now, you know, in the class this morning, I said, whenever you see infinity, it means the whole of this. Because of this infinity, multiplying this, the whole of this becomes 0. But here we have negative, we also have negative. So minus times minus, here will be what? Plus. Then you are using minus s to multiply 0. Anything you use to multiply 0 is 0, two of us. So here will be plus exponential 0 all over s. Then go back to elementary algebra and the 1. Anything raised to power 0 is what? 1. So here is what? So this satisfies the proof. Do you understand? So let's proceed to solve my example. I don't know whether you people still have another question. Amen? Okay, we can proceed, right? It's okay. So let's proceed. The class is very few. Please wake your friends who are still sleeping. Okay, so let's move further to consider more example. I think after this class, go back to your past questions. You'll be able to solve, attempt some of the questions. Okay, we have here show that Laplace of exponential at is equals to 1 all over s, 1 all over s minus a. It's simple as ABC. I'm going to break it down for you. Is that clear? It's okay. So at this point, let's write solution. Then what should first come into your mind is to remember the formula of Laplace transform. Laplace transform is f of t equals to integral, integral 0 to infinity, excuse me, exponential minus st f of t dt, right? Amen? Okay, so if you agree with me, so this implies that, let's come back here, this is the function, right? It means your f of t is this, two of us, according to, look at it here. Look at it here. So you equate it with this. Can you see now? So this will now be a Laplace, open bracket, exponential at will now be equals to integral 0 to what? Infinity, exponential minus st. Our f of t here is exponential what? Times exponential at, amen, times dt. Amen? Yeah. Do you agree with me? Or you are still confused, please? Do you agree with me? Hope you are following. So we can proceed, right? It's okay. So if you agree with me, it's okay. So here, if I may ask, when you have something of this form, what will first come into your mind? I know you've forgotten, but if I were you, let's go back to indices. Assuming we have a raised to x raised to power n dot x raised to power n. Can you see now? So when you see the basis, you discover that the bases are the same. and they are multiplying, what should first come into your mind? It means you have to add the powers, true or false. So pick one of the bases, x raised to the power of n plus what? N. So when you look at this exponential, that is what we are supposed to do here. So if you agree with me, amen. If you agree with me, this is what we are supposed to have. This is equals to integral 0 to infinity, then exponential minus st, because the bases are the same, plus at dt. Can you see now? So if you can see what I am saying, this is the same thing as integral 0 to infinity. Something is common. Look here. Something is common. True or false? What is common? T is common. T and negative sign, you factor it out, exponential minus open bracket s minus a t dt. Can you see now? Because by the time you use this to multiply this, you get minus st, then use minus to multiply, you get plus 80. True or false? Yeah. So I think this reminds us of our this morning class. True or false? Yeah. We did something like this in the class. So when you integrate functions of this form, you are supposed to have minus exponential minus open bracket s minus a t. Amen. The t, sorry, no more the t, all over what? This s minus a at 0 to infinity. Can you see now? Any question at this point? Please look at the board before we proceed further. Do you have any question? No question. Oh, I don't understand. Solomon, where? Solomon, you said you don't understand. Where? Solomon, are you sure you were in the class this morning? I don't think. Solomon, talk to me. You say you don't understand. Solomon, where are you? Favor, Peter. Get the numbers from your course rep. Your course rep will give it to you. After solution from the second line. Oh, from the second line. Okay. From here, but I thought I tried to, from the second line, look at it now. This is the formula. Exponential, that is integral 0 to infinity exponential minus st f of t dt. True or false? So this is the Laplace. Can you see now? So look at the function given to you, Laplace of exponential at. So instead of f of t, this is what you are going to write, exponential at. Look at it here. Look at it here. Can you see now? So it means this and this will multiply each other since the bases are the same. You apply what? Indices now. Go back to your ND1 mathematics. You apply indices, and the indices is multiplication law. You are going to use multiplication law to do the algebra. True or false? Since the bases are the same, you have the powers. Look at it now. See the powers of this exponential minus st. Then see the powers of this exponential. Is it not 80? Look at it here. We now add the powers exponential minus st plus 80 dt. So as it is now, excuse me, you ask yourself, okay, if, let's look at it, when you have something minus 80 plus minus st plus 80, then you put it in brackets, or you want to factor the common factor here. Look at it, what is common here? something is common. We have t here, we also have t here. But we have negative sign here, we have plus here. So minus and t are common. So you factor them out. Even if you want to write it this way, you are still right. Minus a, yeah, you are still right. But the better way to write it is minus open bracket s minus a t, because of the integration we are integrating. So it's better it is be in this form. Do you understand? Any question again? Solomon Peter, do you understand? Yes or no? Are you following? 33 said he is following. That is nice. Please, everybody should like. It's very important. Then after the class, you share. It's okay. So we can proceed, right? Glory, you are following, right? I love that. Understand? I'm following. Yes, I'm following. I love that. Ezekiel, thank you. Okay, so let's proceed. Okay? Let us proceed. So here we have, we now subtract the lower limit from the upper limit, right? So when we do that, we are going to have, okay, let's do it here, minus exponential minus open bracket s minus a. Anywhere you see t, you write infinity all over s minus a. Then minus, already this carries minus, two of us. Then open small bracket minus exponential minus open bracket s minus a. Anywhere you see t, you write what? 0 times 0. Then all over s minus a, right? Can you see now? Okay, so as long as infinity exists here, whole of this is 0, two of us. So this place is 0. Then minus times minus will give us plus. Then this times this is 0. Exponential 0 all over s minus a. And anything raised to plus 0 is what? Is 1. So 1 all over s minus a. This is the answer. Any question before we move further to consider more examples? Do you have any question? And when you look at these things, the properties we are solving, these properties we are solving, I think they are part of your exam past question. Oh, stick, you are lost. Where? Saint Stick, are you part of us? You don't have a number. I think the next example I want to cite, I want to display here. I think you understand it from there. Okay, so let me take it off. Yeah, here is another example that we want to look at. Here is another example that we want to look at. It says show that Laplace of t raised to power n is equals to n factorial all over s raised to the power of n plus 1. Yeah, if I'm not mistaken. Yeah. So, should in case you come across this in your test or exam is simple as ABC, please look at the board, everybody. Make sure you copy what we are doing and take notes. Is that clear? Okay. So far, so good. So we now write a solution. We recall our Laplace transform f of is equals to integral 0 to infinity exponential minus st f of t dt, right? So this implies that our f of t here is what? T raised to power what? N. So it means a Laplace of t raised to power n is equals to integral 0 to infinity, then exponential minus st. F of t is what? T raised to the power of n dt. So at this point, what you are going to do that will favor you because of t raised to the power of n, we are going to use substitution. Is that clear? Do you understand? We are going to use substitution. Is that clear? Are you following? Look at the board, please. Look at the board. We are going to use substitution. So the substitution, because of what is there, now say let st equals to x. Then if we do that, because we want to substitute in for t, if we do that, make t the subject of the formula. It means if we make t the subject of the formula, here is your GS2, GS3 maths. It means you divide through by s, so our t will now be x all over what? S, right? Then, if we differentiate this with respect to x and t, both sides, if we differentiate this with respect to t, the left hand side we are going to have dt s dt equals to differentiate x, we are going to have dx. So it means make the t the subject of the formula. It means we are going to divide through by s. So it implies that our dt will now be equals to ds all over the x all over s. So far so good. So now here, anywhere you see t, you write x all over s. Then anywhere you see dt in this integral, you write the x all over what? S. Can you see now? So if you agree with me, we have t here, we have the t here. So we are going to use this to replace this t. Then we use this to replace the t, true or false. So here will now be integral 0 to infinity exponential minus st. Instead of t, we now write open bracket s all over x all over s. Then, mind you, we have t raised to the power of n, true or false. So raised to power n. Then what is our dt? The t here is times the x all over what? Then at the same time, we are going to substitute in for t here. Our t here is this, true or false. So it means this is how we are going to write it, exponential minus s times x all over s. Can you see now? So this implies that I don't know whether you understand what I'm trying to say. Any question? My battery is down. 008. Okay, so let's proceed. Okay, so if you can see what I am saying here, look at the board. This and this will go, two of us. Yeah, true. So here will now be integral 0 to infinity exponential minus s, then all in bracket, in indices, when we have x raised to the power x all over s, x all over s raised to the power n, this is the same thing as s raised to the power of n all over s raised to the power of n. Take note. So here we are going to have x raised to the power n all over s raised to the power of n dot ds all over s. So if you can see what I am saying, look at the board. This is s, this is s. So we apply indices, multiplication law. That is, look at it here. I know some of you are blind mathematically. When we have, look at it here. When we have something of this form, x raised to the power of n and s raised to the power of n times, mind you, the s all over s, the s all over s. This is the same thing as we can apply indices to have it in this form, x raised to the power of n dx all over x raised to the power of n. Here there is an invisible one raised to power what? N plus 1. True or false? We have applied what? Multiplication law. That is why they taught you arithmetic algebra. It's very important. It's okay. So far so good. So here we are going to write integral 0 to infinity exponential minus x, then times x raised to the power of n all over s raised to the power of n plus 1 dx. Can you see now? So mind you, this is a constant, so we can factor it out. This is the same thing as 1 all over s raised to the power of n plus 1 integral 0 to infinity, then exponential minus x times x raised to the power n dx. Can you see now, please? Any question? Any question? Yes or no? We can proceed. Zainab, I know you are just coming. Okay, no question. So far, so good. So what we need to do, I want to clean this up. Let me clean this up. What we need to do, we have to write that note that integral 0 to infinity exponential minus x times exponential times x raised to the power n times dx is equals to, this is gamma function n plus 1, gamma function of n plus 1. Can you see now? So this function is equals to this gamma function of n plus 1. So I can claim this, right? Gamma function of n plus 1. Then, if you agree with me, this implies that this answer will now be equals to 1 all over s raised to the power of n plus 1 times gamma function n plus 1. Then also note that the gamma function n plus 1 is equals to n factorial. Can you see now? This is equals to n factorial. So you can now see that. You don't need a prophet to tell you. Now see the final answer, Laplace of f of Laplace of t raised to the power n now be equals to, instead of this gamma function, we write n factorial. So 1 times n factorial is the same thing as n factorial all over s raised to the power of n plus 1. Can you see now? Any question, please? Ask. No question? So we can proceed further, right? To solve more examples. It's okay. You said we should proceed further to solve more examples. Fine and good. It's okay. So let's solve another examples here. I think we have here cos 80. Okay. Okay. It's okay. Another example is prove that cos 80 is equals to 1 all over s square minus a square. Right? Oh, s, I think s, if I'm not mistaken, prove that s. Okay. Yeah. That is that here. Let's look at the boards. I think I told you that immediately after this class, go back to your past questions. You will see similar examples that we have solved as questions, and it will help you. So if you don't understand, you go back to the video, it will help you and guide you. Is that clear? It's okay. So I told you that we are talking about Laplace transform. So the formula is very important. F of t close bracket equals to integral 0 to infinity exponential minus st f of t dt, right? Is okay. So far so good. You don't need a prophet to tell you. Yeah. I want us to note that the easiest way, note that Laplace transform of cos 80 is the same thing as exponential 80 plus exponential minus 80 all over what? 2. Can you see now? So it means we can rewrite this in this form. This is the same thing as exponential at all over 2, then plus exponential minus at all over what? 2. This thing is the same thing as this. Please take notes. Is that clear? Just like a plus b all over 2. You know that this is the same thing as a all over 2 plus b all over 2. Because we want to do something. Please take note. Is that clear? Very important. Okay, so if you agree with me, it means this is the same thing as this. Take note. It's very important. So if you agree with me, it means if you agree with me, integral 0 to infinity exponential minus st, right, times our f of t is this. Can you see now? Cos 80 gives us this, and it's the same thing as this. So times, put it inside the bracket, exponential 80 all over 2 plus exponential minus 80 all over 2 close bracket, the what? The t, right? So at this point, we are going to apply indices here. Two of us, because the bases are the same, this and this will multiply, this and this will multiply. Two of us, go back to your indices. The integral will now be in this form, exponential minus st. So, okay, dot exponential, let me just break it down, raised to the powers of 80 dt, right? Let me put it inside the brackets. Okay, let's forget about the t. Put plus exponential minus st dot exponential minus 80 all over 2, then close the bracket, dt. Do you understand up to this point? Please look at the board. Breaking it down for you. The link I said you have to share is this video now. This video you are watching now, immediately after the class. You share it your Facebook or TikTok or anyone. Is this video I'm talking about? Is that clear? It's okay. So we can proceed, right? Hope you guys are enjoying the class. Are you enjoying the class? I think we are left with 11 minutes. This is 49 minutes, so we are left with 11 minutes. WhatsApp, your status, WhatsApp status is okay, or any group you belong to on WhatsApp is okay. Yeah, it's okay. So far, so good. So if you agree with me, here we are going to go back to your ND. Your elementary mathematics, we will apply what? Apply indices, multiplication law here. So if you can see what I am seeing here, integral 0 to infinity exponential all over, because note that there is an invisible one here. 1 times 2 is 2. So minus st plus 80, 2 of us, plus 80 is the same thing. Then plus the same thing, 1 all over 1, exponential minus st plus open bracket minus 80. I'm breaking it down for you guys. All over 2, then put it inside the bracket, dt. Can you see now? So I want to clean this up. Okay, let me still continue. This is equals to integral 0 to, so here something is common. If you can see what I am saying, here is a minus. Go back to our previous example, minus and t, they are common, minus t, true or false. The t, right? Then plus integral 0 to infinity. Here plus times minus, minus, true or false. Exponential all over 2 minus s. Okay, minus is common, so open bracket s plus a at dt. Because by the time you use this to multiply this, we are going to have minus st. Then here in between them will be minus because of this plus times minus. So minus t times a is going to be minus a. Take note, please. Is that clear? Any question? So as you can see now, let me clean it up. As you can see now, you don't need a prophet to tell you this is let's integrate the first part, this one. So if we integrate it, we are going to have minus exponential minus open bracket s minus a close bracket t all over s minus a at 0 to infinity. Then what we have here plus the same thing applicable here. Integrate this function. We are going to have minus, oh sorry, I think we missed 2 here. Yeah, so here is supposed to be let me rewrite it. I want to miss something. Here is supposed to be equals to 1 all over 2. Put it in a bigger bracket, then factor out the 1 all over 2, then integrate this. We are going to have minus exponential minus open bracket s minus a t all over s minus a, then at 0 to infinity, then plus the same thing, 1 all over 2 is common, factor it out, open the bracket. If you integrate this, you are going to have minus exponential minus open bracket s plus a t all over s plus a. Then at 0 to what? Infinity, right? Are you following? It's okay. So far so good. We have to substitute. Keep this 1 all over 2 aside. Just keep it somewhere. Just substitute for this 1 all over 2. When we substitute the lower limits from the upper limits, this is how it will be. Minus open bracket s minus a times infinity all over s minus a, then minus again, true or false. Yeah, then the same thing, exponential minus open bracket s minus a times 0 all over s minus a. Move me to this side. Then what we have here plus factor 1 all over 2 out, open bracket, the same thing applicable here. subtract lower limit from the upper limit. So it will be minus exponential minus s plus a t. Anywhere you see t, you write infinity. Then all over s plus a. Then minus open bracket minus exponential minus open bracket s plus a all over s plus a open bracket t